So, good morning to all of you. Is my AV is okay? Thank you. So, in the last class, we were discussing about economic dispatch, neglecting losses, but with generator limits. This is what we were discussing, isn't it? So, in this one, you can see here. So, these are the two constraints we have considered. So, this objective function is this one, that is minimizing the total cost of production or total generating cost CT we have to minimize, subjected to the constraint, the total generation is equal to total load demand. This is what we have studied in the previous case, economic dispatch, neglecting losses and with no generator limits. But when you consider with the generator limits, but still neglecting losses, one more constraint will be added to this optimization model. That is nothing but real power generation at ith bus should be greater than or equal to P minimum and less than or equal to Pi maximum. So this is the extra thing you are going to get. So we have to apply Kuntakar conditions which are going to complement our Lagrangian conditions which has been applied on equation 4. Lagrangian multiplier we have applied it. So therefore, what is the necessary condition for optimum dispatch is incremental fuel cost will be same for all the plants. Incremental fuel cost will be same for all the plants or the units as long as the real power generation is within the minimum and maximum limits. However, whenever this generation violates the lower minimum limit or the upper limit maximum limit, then the condition for optimal dispatch will be like this. So the incremental fuel cost will be less than or equal to lambda if Pi is equal to Pi max. That means when this condition is true, whenever the real power generation exceeds the maximum value, then set that maximum value is equal to your real power generation. You assume it, the real power generation at bus 4 is the maximum value is 100 megawatt. Clear? Now, the real power generation at fourth bus is 110 megawatts is the actual value which is generating. That means what is the maximum limit on the fourth generator? Generating unit is 100 megawatts. But what is the actual generation? It is happening 110. That means it is violating the maximum value. However, whenever it violates the maximum value, don't operate that generator at 110, but operate at its maximum limit of 100 megawatt. Clear? So that means what? Assign the maximum value to the generation. Assign maximum value to the generation. In such condition, the incremental fuel cost will be less than or equal to your lambda. Fine. The other condition for optimal dispatch is whenever this real power generation, take pointer, whenever this real power generation violates the minimum limit. That means suppose minimum generation at ith unit is say 40 megawatt. Assume it 40 megawatt. But the actual generation which is happening at ith generation is 30 megawatts. But minimum should be for economical reasons. The minimum generation should be 40, but it is generating 30 megawatts. So you cannot operate that generator at 30 megawatts. So what you have to do? Operate that one with 40 megawatt. That is minimum value. So that is another condition we are going to get. That is so that minimum value assigned to your real generation. Whenever it violates the minimum value, assign the minimum value to the actual value of generation. In such case, the condition will be the incremental fuel cost will be greater than or equal to lambda. Please remember these three conditions. The necessary condition for optimal dispatch. For this case, economic dispatch, neglecting losses, and considering the generator limits. Understood? Just there are latecomers are there. Let me admit them. Okay. Hope you understood this one. So in this case, so the same condition only, I have given it in terms of statements. As soon as any plant reaches the maximum or minimum, the plant becomes clamped or pegged at that limit. If it exceeds maximum limit, then that particular valve plant or unit will be clamped or pegged at maximum limit. If it violates the lower limit, then the particular plant will be pegged or clamped at that minimum value. So that's what I given. In effect, the plant output becomes constant. Whenever it is clamped or pegged at its lower or upper limit, then the output of such a plants will become constant. So that is what I have explained it. Okay. So then coming back to this one, only the plant which is not violated must operate at equal incremental fuel cost. Suppose you assume it, three generators are there. Understood? So second generator has violated the maximum limit. So therefore, that second generator will be clamped or pegged at its maximum limit. And you cannot use this second generator further. So any increment in plant generation is there, then that will be taken by generator 1 and 3. Generator 1 and 3, because the plant 2 violated the limit, so it has been clamped at its value, minimum or maximum value, so that it cannot be used for further operation. The plant output of generator 2 will become constant. That is the meaning of this last statement. Hope you understood this one, isn't it? So this is what we have discussed in the previous class. Again, I have explained it because we are going to solve one numerical problem based on this one. So please keep it in mind here, whatever has been given, so that you have to keep it in mind. Okay. Next, coming back to this one. So let us take one numerical problem. This is a numerical problem. Yes, Mohan Kumar, are you there? Mohan Kumar, are you there?
Yes, sir.
Tell me the answer. When it violates maximum limit, what we should do? Whenever a generating plant violates its maximum limit, what we should do? Mohan Kumar. No answer? This is
Don't know, sir.
huh? Yes. You don't know the answer because you don't log in time. Okay, next. So let us take this numerical problem based on our case study, which we are studying it. So that is nothing but economic dispatch, neglecting losses, but considering generator limits. Now you read this problem carefully. Incremental fuel cost. So please remember, incremental fuel cost means it is a first derivative. First derivative, that means dC to dPg. Always incremental fuel cost. If it is total cost, means it is C. For plant 1, it is C1, plant 2, C2, etc. So please have this one in your mind. Incremental fuel cost means what is the unit for incremental fuel cost? It is rupees per megawatt hour. What is the unit for cost of a plant? It is rupees per hour. Rupees per hour. Understood. So this is what we are having it. So it has been given for two units. That is, this is first unit and this is second unit. See, one thing you should consisting of, suppose if you take thermal station at Raichur thermal station, how many units are there? Generating units are there? In Raichur thermal station, how many units are there? How many units are there? Anyone? The people who are from Raichur, you can answer Raichur and surrounding places.
8 units, sir.
Huh?
8 units are there.
8 units
Each of 1,720 megawatts.
1720. Na. Please check. Who is this?
1,720.
Who is this?
Mohan Kumar.
First check it out. 1007 megawatt each unit. First you
210,
check.
250.
Huh?
Total capacity of 1,720 megawatts.
Total
Yes,
210
sir.
ಮತ್ತೆ 250 ಸರ್
210. Lokesh.
210 7 ಯೂನಿಟ್
Yeah.
ಒಂದು ಬಂದು 250.
Okay. So therefore, here plant may be consisting of multiple units. Please understand, here plant may consisting of multiple units. So in one particular plant, we are having 2 units. So this is first unit, this is second unit, incremental fuel cost. What do you mean by incremental fuel cost? So if you want to produce an additional power, what is the cost, that incremental, what is the cost involved in generating that additional power? That is your incremental fuel cost. Understood? So that has been given for plant C1 and plant C2. Now assume both the units are operating at all times. In a plant there are 2 generating units. The incremental fuel cost has been given. So assume that both the units are operating all times and total load varies from 40 megawatt to 250. Total load varies from 40 megawatt to 250. Understood? So this is PD. PD is varying because you know that load is not constant. It keeps on varying it, isn't it? So depending on the condition, morning load variation will be different. Each hour, each day, it will be varying it. So what is the load variation? It is 40 megawatt to 250 megawatt. It is varying it. Okay, so therefore the maximum and minimum loads on each unit are 125 and 20 megawatt. You see here generator limits has been given. That means what is the minimum loading on plant 1? It is 20 megawatt. Also plant 2, it is 20 megawatt. So what is the maximum load on plant 1 and plant 2? It is 125 megawatt because they are given each unit respectively. How will the load be shared between the 2 units as the system load varies? This is not varies, it is varies here. As the system load varies over the full range. That means when the system load varies till 250 megawatts, how this load will be shared by these 2 units. So what are the corresponding values of the plant incremental fuel costs or plant incremental costs? So this is what the question has been asked. So now what we have to do? So when the load is varying and keeping the generator limits in mind, we have to meet the load demand. There is variation in load demand and how these units are loaded for this variation in load. This is the problem that we are going to deal it now. So as usual, same formulas. One is you should remember the cost equation, incremental fuel cost, then the criteria for optimal dispatch. What is the condition for optimal dispatch? Here generator limits are existing. So what is the condition? We have to see this one. Now let us solve this one step by step. Now you see at light loads, that means minimum load 20 megawatts and 125 megawatts has been given. So at light loads 20 megawatt has been given. Okay. Now substitute this 20 megawatt, that is this is PG generation value. Substitute this one in this incremental fuel costs. That is first equation is DC1 by DPG1 is equal to 0.2 into PG1 is 20 megawatt plus 40. You substitute it. So you are going to get 44 rupees per megawatt hour. Clear? This is 44 rupees per megawatt hour. This is IC, incremental fuel cost. That is nothing but your lambda. Incremental fuel cost is denoted by lambda. Okay, fine. This is how we are getting same minimum load, that is light load, substituted in plant 2. So you are going to get, this is the incremental fuel cost. You see this one, incremental fuel cost. So if you want to generate an additional, that is 20 megawatt power, it is not additional, light load. So it takes 44 rupees per megawatt hour. But the plant 2 takes 35 rupees per megawatt hour. Understood, at light load. So using your common sense, can you tell me which plant you are going to prefer? Which plant you are going to prefer at light loads? Which plant? Sorry, not plant, unit. Which unit you are going to consider at light loads with these values of lambda we got? Yes, I am getting the answer. Okay. Second one. Tushar has given, Sushumna has given the answer. Okay. So the second one, obviously, isn't it? Because the incremental fuel cost is less 35 rupees at light loads. So however, incremental fuel cost for the unit 1 is 44 rupees per megawatt hour. So it is more. So obviously at light load, we will prefer unit 2. So unit 1 has the higher incremental cost. Therefore, operate at its lower limit. Don't operate for higher limits. Understood? We prefer unit 2 to take the additional load. But unit 1 is operating at higher incremental cost. So therefore, you fix the unit 1 at its lower limit. This question is different. The question which I asked was different. Usually only one load is there. If only one load is there, you would have gone for this plant. Understood? But here the load is varying. Here the load is varying from 40 megawatt to 250 megawatt. It is going to vary. Okay, sorry for the disturbance. Okay, so this we would have preferred the unit 2. But now the problem is the variable load is there. So we have to operate unit 1 and unit 2 as load varies from 40 megawatt to 250 megawatt. How we are going to do this one? So for that one, so unit 1 is having higher incremental cost. So therefore, because of 44 is there, so fix this unit 1 at 20 megawatt. Fix this unit at 20 megawatt. Understood? Any additional load is there, that you apply it or give it to unit 2. Unit 2. Why? Because the incremental fuel cost is less. Suppose if the incremental, so till which point we have to give the additional load to this one? Can anyone tell? Unit 1 has got 44 rupees per megawatt hour because higher incremental fuel cost. So therefore, we will fix the unit 1 to operate at 20 megawatt. Any increase in load will be given to the unit 2 because its incremental fuel cost is 35. So till which point we have to give the additional load to this unit 2. This we are not going to disturb. This unit 1 we are not going to disturb. So however, the additional load increase will be taken care by unit 2. But till which point? Tushar has given the answer. Till 125 megawatt you are given. No. This is what it is, should keep it in mind. So Tushar has given 125 till 125 megawatt. The unit 2 has to take care. So here is this thing we have to keep an eye. That's why it is known as economic dispatch. So once when we look into the problem, yes, what Tushar has given 125 megawatt appears to be right, but it is not true. So let us see that one in this example. So this is the thing, first case. Now let us see here. With the increase in the plant output, the additional load should be borne by unit 2 only. This is what I have explained it. Till which point is the question? Till which point is the question? So what happens? Okay, now 20 megawatts is there. Suppose if you are having calculators with you, suppose if the plant output is increased to 40 megawatt or 50 megawatt, what is IC1? What is IC2? IC1 means this one. IC2 means this one. You can calculate it if you are having calculators with you. If the load is varied from 20 megawatt to 50 megawatt, okay, I think it will take time for you people to do it. So that I will be explaining it. You can try it anyway. I think somebody has calculated. 50 is the lambda. So what is this 50, Joshita? What is this 50? Is it lambda value? That is incremental cost for both when 50 megawatt. Okay, that means it is lambda. Oh, okay. Yeah, okay, fine. So that means lambda value is 50. You are getting it, isn't it? So you see now lambda value of both the units has become 50 at 50 megawatt. At 50 megawatt, the lambda value has become same. Then why only unit 2 has to bear the load, isn't it? So this is the question that we should keep it in mind and we should proceed it. So as long as at this point, till this point, I think the concept is clear, isn't it? So unit 1 is pegged at, it is not violated, but still the operating cost is more, that is incremental fuel cost is more. So therefore we will not operate this unit for any additional plant output. Any additional plant output is there, that will be borne by unit only. But till which point? Till this cost becomes same as this one, this has to take load. Once the incremental fuel cost of both the plant becomes same, or at some point this incremental fuel cost will become more, this will become less, then the additional plant output will be taken by this unit. This we have to see. Trade-off, we have to do it. So that is the problem which has been given. How the load be shared between two units as the system load varies over the full range. Clear? That's what we have to see. Okay, till this point you understood, it is clear for you. Now let us take, okay, now you see till IC2 becomes 44. That's what I explained it. That's what I explained it. Any additional increase in the plant output will be borne by this unit only, 2 only, till IC2. IC2 means this DC2 by DPG2. Incremental fuel cost, IC means, till it reaches 44 rupees per megawatt hour. Understood? So keep this point in your mind. Let us prepare the table. You see this one, plant lambda. Lambda means incremental fuel cost, rupees per megawatt hour. Unit 1, what is the generation in megawatt? Unit 2, what is the generation in megawatt? What is the total plant output? PG1 plus PG2. Okay. So when lambda is equal to 35, when lambda is equal to 35, unit 1 has got highest incremental fuel cost. So therefore unit 1 you are going to fix it at 20 megawatt. Clear? So therefore unit 2 also will be at 20 megawatts, because at light loads, what is the lambda value we got? 35. So both should be operated at 20. So total load is, plant output is 40 megawatt. PG1 plus PG2. Why I have shown this one in red? Because for the next incremental fuel cost 44, I am not going to put any additional load on this unit. Still it remains constant. You see, that's why I've written it in red for clear indication. 35 and 44 are the two values of lambda we got at light load, isn't it? So 35, 20 is fixed for unit 1. So therefore, remaining 20 will be taken care by the unit 1. So it will be 40. So when lambda value is equal to 44, I am not going to increase the load on unit 1 because it is held constant 20. So the additional load will be taken care by, sorry, this is unit 2. Here, this is a correction. This is unit 2. That is a correction, please make yourself. So what is the load taken care? That means when lambda is equal to 44, we are not going to calculate unit 1, we are now going to calculate unit 2. So this is equal to, the value of this one will be is equal to, when IC2 is equal to 44, till 44 you have to load only unit 2, not the unit 1 will be held constant in simple way. Till 44 rupees per megawatt hour, unit 1 will be held constant and unit 2 will be loaded. So when lambda is equal to 44, what is the IC equation that we got? 0.25 Pg2 plus 30. This is given in the problem. Is equal to lambda. So what is my lambda? 44. Now you find out Pg2. So that is 56 megawatt. Understood? So this is your 56 megawatt. Hope you understood this one. So what is the load on unit 2 when the lambda value is equal to 44? It is 56 megawatt. So total load will be 56 plus 20, it is 76. Hope you understood this point. How we have to share the load. Now onwards, what we should do? Now what I will do? I will take different values of lambda. I will take different values of lambda. I will calculate what is the load on unit 1 and what is the load on unit 2. Understood? Because these are the, at light loads, we got this 35 and 44. So at 35, 44, this is held constant. This is also 20, total is 40. So at 44, so it is held constant and only unit 2 will take the load. Now onwards, now I am taking different lambda value of lambda is equal to 50. Lambda value is equal to 50. What is the load on unit 1? What is the load on unit 2? I will be calculating using the given equations of IC1 and IC2 in the problem. So let me take. Okay, before moving on to the intermediate values, let me take the maximum load. What is the maximum load? Maximum load that has been given it as 125 megawatt. 125 megawatt. At 125 megawatt, what is the IC1? What is IC2? Let us calculate it here. At 125 megawatt. So in this equation given in the problem, substitute 125. So we are going to get a lambda as 65 rupees per megawatt hour. Then what is lambda 2? Lambda 2 is 61.25. You see this one? Understood? At light load we have calculated. Now at maximum load we are calculating what is the incremental fuel cost of unit 1 and unit 2. And you see 65 rupees per megawatt hour and this is 61.25 rupees per megawatt hour. So what we have to do for both the values of lambda, you have to calculate unit 1 and unit 2 values. These are the values of lambda, but intermediate values also we have to consider. How we have to consider, we will see. So those are the values which we have taken at light load, and these are the values of lambda at maximum load. So both the things we have to calculate. Understood? Now you see this one at 61.25, we are reaching, unit 2 is reaching maximum load. It is taking maximum load 125. But same maximum load taken by unit 1 happens at 65 rupees. At 65 rupees. Understood? So therefore, here I am going to represent 61.2 and here I am going to represent 65. Understood? So what is the loads? I should mention it here. That is my question here. At maximum load, we got two values. So 61.25, I will write it here. Here. Okay. And 65, I will write it here. Because you see at light load 35, 44 we got. So for both the values, we adjusted the load, keeping one constant based on the incremental fuel cost. Now here we got two values, 61.25, 65. What is the unit 1 load? What is the unit 2 load? At 61.2. At 65, what is the load on unit 1? What is the load on unit 2? Intermediate values, we will calculate it later. 125 megawatt, Tushar has given the answer. So I think it disconnected. Can you hear? Is it okay? Can you see? Is it audible? AV? Everything is okay? Hello? Is my AV is okay? Can anyone respond, please? Okay, fine. Thank you. Hope it is okay now. Okay, now 125 megawatt, Tushar has given the answer. Tushar, can you tell me this 125 megawatt is the load on which unit? On which unit? 125 megawatt on which unit? Okay, somebody has given Sumant.
Unit 2.
Yes?
Unit 2.
Unit 2, 125 megawatt for 61.25 or 65?
Sir, for both the sir, for both.
Oh, for both. Okay. So anyway, okay, Abhishek Sharma has given unit 2. Sumant has given already the answers. 106, 60 at 61.5. Sumant has given the answer. On loading on unit 1 is 106.25 megawatt. And loading on unit 2 will be 125 megawatt. And at 65, the loading on unit 1 will be 125, unit 2 will be 140. Here, Sumant, you have done a mistake. Here you have done a mistake. The first one at 61.5, okay. Now I'm going to explain before showing the values. At 61.25, unit 2,
140.
unit 2 already has reached the 125 megawatt maximum limit. But at which value the unit 1 is reaching the maximum value? At 65, isn't it? So that means what? At 61.25, the unit 2 is operating at 125 megawatt. Unit 2 is operating at 125 megawatt. So what is the loading on unit 1? What is the loading on unit 1 at 61.25? What is the loading on unit 1 at 61.25? That means in the same procedure you follow it, like how we have calculated 56 here. Same way you calculate it at 61.25. That means this equation, this is your PG1, equated to 61.2, and find out PG1. That will be your loading. So let us see here. I will show it to you. Now you see this is the values. So Sumant has given the right answer here for this one. At 61.25, the unit 2 is already operating at 125. But what is at 61.25? What is the loading on unit 1? So unit 1 incremental fuel cost is there, no? There equate that one to 61.25. Calculate PG1. Hope you understood that one. That means here, this equation. In this equation, 0.2 Pg1 plus 40 is equal to 61.25. So find out Pg1 for a given value of lambda. So there you are going to get that value what I have shown here. This one, okay, 56. This is the values you are going to get. Hope you understood this point. Now at 65, now I am going to write 65 here. 65 here. What is the load on unit 2 at 65? Unit 2. Will it increase or decrease? Now at 65, I am going to write it here. Now I want to find out the loading on unit 1 and unit 2. Now at 65 incremental cost, what is the loading on unit 2? Shanti Prasad has given 140. Abhishek has given the answer. It will be same on unit 2. It will be same on unit 2. This is the answer given by Abhishek. Now you see, I have shown it in already in red color. Unit 2 already operating at its maximum limit, 125 megawatt. So any additional load is there beyond this one, it will be taken care or borne by unit 1 only, like how I have explained it here. Understood? So here already this has reached the maximum limit, 125 megawatt is the maximum limit. So already it is reached. Further increase in the lambda value, increases the loading on unit 1 and unit 2. But the additional increase in load will not be taken by unit 2 because already it has reached the maximum value of 125. So therefore at 65, the loading on unit 2 will remain same, held constant, pegged at its maximum limit. Maximum. Now you told 140. Now whatever the statement I made will become true here. Now 140, some of them has given 140 at 65. Is it 140? Is it violating the maximum limit? Yes or no? Yes, because what is the maximum limit on unit 2? 125. But actually you are getting 140. So you cannot operate it at 140 because it is violating the maximum limit of 125. So in such cases, what you have to do, assign the maximum value to the generation. So therefore that unit will be clamped or pegged at its maximum limit. So therefore this value also will remain 125. And at 65, at lambda is equal to 65, what is the generation you find out? What is the generation you find out? Those values you put it. So now you see DC1, okay. I'm giving it wrong, this one. Is it clear? So that's what we are going to get it. Okay, PG1, let me, I think order is missing here. Okay, this I will be showing it later. So explanation I given it because the animation order has been changed. So that's why you are not getting it. Okay, anyway, this is 65, so you will get it. But after doing this row, substitute some values of lambda in between. Substitute some values of lambda in between. So I am taking lambda is equal to 50. Lambda is equal to 50. So find out what is the loading on unit 1 and unit 2. So unit 1, when lambda is equal to 50, substitute this one in the incremental fuel cost equation. So you will get Pg1 is equal to 50 megawatt. So Pg1 is equal to 50 megawatt. Will both the output be 125? I'll come to that point. Already I've explained. Now I will show that point later at the end because the animation order has changed here. With 65 as lambda, I will come to that point, Saksha. When 65, I'll come to that point. I have given theory, I'll come to those values. Now what I am doing, I am calculating the loading on unit 1 and unit 2 between these values. So substitute 50, Pg1 is equal to 50. In the incremental fuel cost second equation, when lambda is equal to 50, what is Pg2? It is 80. So I have written it 80. So total is 130. Now when lambda is equal to 55, here I am going to write lambda is equal to 55. So what you are going to do, in the same equations, you substitute 55, find out Pg1. Substitute 55, find out Pg2. Those values you put it here. So those values you have to put it here. So these are the values you see. 55 and lambda is equal to 55. Unit 1 is 75 megawatt. Unit 2 is 100 megawatt. Total is 175. So when lambda is 60, I am going to take some other value. Some values in between I am taking it. Lambda is equal to 60. That means in this equation, replace this one with 60. Find out Pg1. Here also, replace this 50 by 60 lambda value. Find out Pg2. Those values you have to fill it here. 60, this is 100 megawatt, 120 megawatt. Then after 60, 61.25 we are reaching it. So this, you know that one, 125, 106, I've explained it already how we got. Now the last value will be 65. Now you see, at 65, this will not be considered. This also kept 125. But at 65 lambda, what is the loading on unit 1? Can anyone tell now? At 65, so obviously this is 140 you are calculated, but 140 is exceeding the maximum limit. So therefore 140 you cannot keep it. So keep 125 as it is. That means it is clamped to maximum value. Now when lambda is equal to 65, what is this value? That I am asking. So that is the question. So answers I am getting it. So it is 121.25, 125 has been given by Abhishek and Shanti Prasad. Okay, Tushar has given 125. So when it is equal to 65, what is the unit 1 loading? Already it is there. You see, already it is there. At 65, it is maximum. You can see there. So it is 125, 125. Total megawatt is 250. Now you see at 65, both the units are operating at its maximum limit. This also I would have shown it in red. You see 125, 125. Because actually when you calculate that unit 2, you will get 140, which is violating the maximum limit. So, but you cannot operate at 140, isn't it? So it is pegged or clamped at its maximum value 125 only. The additional load will be taken by unit 1 only when lambda value is equal to 65. So what is that 65? What is unit 1? It is 125. So you see this one. Now you see at unit 1, minimum loading is 20, maximum loading is 125. Unit 2, minimum loading is 20 and maximum loading is 125. Only thing is these two you have to keep it in mind. When you have to make constant at minimum load, at maximum load. This is very important, and intermediate values for different values of lambda, you calculate Pg1, Pg2 using your incremental cost equations. This is key point. Understood? When you have to make constant for which unit, that is very, very important, these two units. Now you see total output is varying from 40 to 250 megawatt. Total one is varying from 40 to 250. That's what has been given in the problem. Hope you understood this one. Now for this one only, you can draw the curves for different values of lambda, taking these values. Understood? So you can plot it. This is the plant output for 50 megawatt, 100 megawatt, 150, etc. What is the incremental fuel cost? So this is the nature of curve you are going to get. Understood? This is lambda versus plant output. That means lambda versus plant output, this one. So 35 to 65, and these are the corresponding values you have to plot. So this is the nature of plot you are going to get. From this one, suppose from this plot, you can find out why we are getting two values of lambda for 2 units. Because lambda is equal for all ICs. Lambda is not equal. Lambda is See, DC1 by DC dPg is equal to lambda. DC2, but cost equations are different. Cost equations are different. Understood? So therefore, lambdas are also you will be getting different values. Lambda also you will be getting different values here. Hope you understood that one. Now you see, at this is 175. At 175, I will say at 175, what is the loading? What is the loading on unit 1 and unit 2? At 175 megawatt, sorry, at this is a plant output, 175. Total plant output is 175 megawatt. At 175 megawatt, what is the value of lambda? 55. Understood? At 170, this is 150 means this is 175. At 175, the lambda value is 55. So therefore, what is the individual loading on plant unit 1 and unit 2? This 55 lambda, you substitute in these equations, you will get Pg1, Pg2. 55 you substitute it here. So you will get Pg1 and Pg2. Understood? You see at 175, same values you will get it. At any value, looking into this graph, you can find out what is the loading for each plant output. Suppose this is 200 and here it is 225. At 225, what is the lambda value? So somewhere 61 you are going to get. So at lambda is equal to 61, what is the value of Pg1, Pg2? In the incremental fuel cost is substituted, you can find out. Clear? Any doubts? I will clarify it. So I will continue this one in the next class. Saksham, hope it is clear for you. Cost equations are different. So shall I end the class? Okay, fine. Still, if you have any doubts, you can ask me, Saksham, later. Thank you, one and all. Take care. Bye.